The following is a conversation with Ian Hutchinson, a nuclear engineer and plasma physicist at MIT. He has made a number of important contributions in plasma physics, including the magnetic confinement of plasmas, seeking to enable fusion reactions, which happens to be the energy source of the stars, to be used for practical energy production. Current nuclear reactors, by the way, are based on fission, as we discuss. Ian has also written on the philosophy of science and the relationship between science and religion, arguing in particular against scientism, which is a negative description of the overreach of the scientific method to questions not amenable to it. On this latter topic, I recommend two of his books. His new one, Can a Scientist Believe in Miracles?, where he answers more than 200 questions on all aspects of God and science, and his earlier book on scientism called Monopolizing Knowledge. As you may have seen already, I work hard on having an open mind, always questioning my assumptions, and in general marvel at the immense mystery of everything around us and the limitations of at least my mind. I'm not religious myself, in that I don't go to the synagogue, a church, or mosque, but I see the beautiful bond in the community that religion at its best can create. I also see, both in scientists and religious leaders, signs of arrogance, hypocrisy, greed, and a will to power. We're human, whether Buddhist, Christian, Hindu, Jewish, Muslim, agnostic, or atheist. This podcast is my humble attempt to explore a complicated human nature. What Stanislav Lem in his book Solaris called our own labyrinth of dark passages and secret chambers. I ask that you try to keep an open mind as well, and be patient with the limitations of mine. Quick summary of the ads. Two new, amazing sponsors, Sunbasket and PowerDot. Please consider supporting this podcast by going to sunbasket.com/Lex and use code LEX at checkout, and going to powerdot.com/Lex and use code LEX at checkout as well. Click the links, buy the stuff if you like. Just visiting the site and considering the purchase is really the best way to support this podcast. It's how they know I sent you, and based on that, they might sponsor the podcast in the future. If you enjoy this thing, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, or connect with me on Twitter at Lex Friedman. As usual, I'll do a few minutes of ads now, and never any ads in the middle that can break the flow of the conversation. This show is sponsored by Sunbasket. Visit sunbasket.com/Lex and use code LEX to get $35 off your order and to support this podcast. Sunbasket delivers fresh, healthy, delicious meals straight to your door. As you may know, my diet is pretty minimalist, so it's nice to get some healthy variety into the mix. They make it super easy with everything pre-portioned and ready to prep and cook. You can enjoy a delicious, healthy dinner in as little as 15 minutes. I just ordered my first set of meals. Haven't gotten them yet, but I can't wait. I just finished the 6-mile run and 1,000 bodyweight reps, and I'm starving. But let me risk listing the actual menu items that I ordered because they sound delicious. Italian sausages and vegetable skewers with 2 romescos. I don't actually know what romescos are, but the pictures looked awesome. And pork fried cauliflower rice with carrots and peas. By the way, cauliflower rice is one of my favorite things ever. Right now, Sunbasket is offering $35 off your order when you go right now to sunbasket.com/Lex. They told me to say right now with urgency. So pause this podcast and go to the website and make the purchase, or just go to the website and check it out. And enter promo code LEX at checkout. This show is also sponsored by PowerDot. Get it at powerdot.com/Lex and use code LEX at checkout to get 20% off and to support this podcast. This thing is amazing. It's an eStim, electrical stimulation device, that I've been using a lot for muscle recovery recently, mostly for my shoulders and legs, as I've been doing the 1,000 bodyweight reps and 6 miles every day, as I just finished. They call it the Smart Muscle Stimulator, which is true, since the app that goes with it is amazing. It has 15 programs for different body parts and guides you through everything you need to do. I take recovery really seriously these days, and PowerDot has been a powerful addition to the whole regime of stretching, ice, massage, and sleep and diet that I do. It's used by professional athletes and by slightly insane, but mostly normal people like me. It's portable, so you can throw it in a bag and bring it anywhere. Get it at powerdot.com/Lex and use code LEX at checkout to get 20% off on top of the 30-day free trial and to support this podcast. And now, here's my conversation with Ian Hutchinson. Maybe it'd be nice to draw a distinction between nuclear physics and plasma physics. What is the distinction?
Nuclear physics is about the physics of the nucleus, and my Department of Nuclear Science and Engineering at MIT, is very concerned about all the interactions and reactions and consequences of things that go on in the nucleus, including nuclear energy, fission energy, which is the nuclear energy that we have already, and fusion energy, which is the energy source of the sun and stars, which we don't quite know how to turn into practical energy for humankind at the moment. That's what my research has mostly been aimed at. But plasmas are essentially the fourth state of matter. So if you think about solid, liquid, gas, plasma is the fourth of those states of matter. And it's actually the state of matter which one reaches if one raises the temperature. So cold things, like ice, are solid. Liquids are hotter water. And if you heat water beyond 100 degrees Celsius, it becomes gas. Well, that's true of most substances. And plasma is a state of matter in which the electrons are unbound from the nuclei, so they become separated from the nuclei and can move separately. So we have positively charged nuclei, and we have negatively charged electrons. The net is still neutral, electrically neutral, but a plasma conducts electricity, has all sorts of important properties that are associated with that separation. And that's what plasmas are all about. And the reason why my department is interested in plasma physics very strongly is because most things, well, for one thing, most things in the universe are plasma. The vast majority of matter in the universe is plasma. But most particularly, stars and the sun are plasmas because they're very hot. And it's only in very hot states that nuclear fusion reactions take place. And we want to understand how to implement those kind of phenomena on Earth.
Maybe another distinction we want to try to get at is the difference between fission and fusion. So you mentioned fusion is the kind of reaction happening in the sun. So what's fission and what's fusion?
Sure. Well, fission is taking heavy elements like uranium and breaking them up. And it turns out that process of breaking up heavy elements releases energy.
What does it mean to be a heavy element?
It means that there are many nuclear particles in the nucleus itself, neutrons and protons in the nucleus itself, so that in the case of uranium, there are 92 protons in each nucleus and even more neutrons, so that the total number of nucleons in the nucleus, nucleons is short for either a proton or a neutron, the total number, might be 235, that's U-235, or it might be 238, that's U-238. So those are heavy elements. Light elements, by contrast, have very few nucleons, protons, or neutrons in the nucleus. Hydrogen is the lightest nucleus. It has one proton. There are actually slightly heavier forms of hydrogen, isotopes. Deuterium has a proton and a neutron, and tritium has a proton and two neutrons, so it has a total of 3 nucleons in the nucleus. Well, taking light elements like isotopes of hydrogen and not breaking them up, but actually fusing them together reacting them together to produce heavier elements, typically helium, okay, helium is a nucleus which has 2 protons and 2 neutrons. That also releases energy. And that or reactions like that, making heavier elements from lighter elements, is what mostly powers the sun and stars. Both fusion and fission release approximately 1 million times more energy per unit mass than chemical reactions. So a chemical reaction means take hydrogen, take oxygen, react them together, let's say, and get water. That releases energy. The energy released in a chemical reaction like that, or the burning of coal or oil or whatever else, is about 1 million times less per unit mass than what is released in nuclear reactions.
So, but it's hard to do.
It requires very high energy of impact. And actually, it's very easy to understand why. And that is that those 2 nuclei, if they're both, let's say, hydrogen nuclei, one is, let's say, deuterium, and the other is, let's say, tritium, they're both electrically charged. And they're positively charged, so they like charges repel. Everyone knows that, right? So basically, to get them close enough together to react, you have to overcome the repulsion, the electric repulsion of the 2 nuclei from one another. And you have to get them extremely close to one another in order for the nuclear forces to overtake the electrical forces and actually form a new nucleus. And so one requires very high energies of impact in order for reactions to take place. And those high energies of impact correspond to very high temperatures of random motion.
So that's why you can do something like that in the sun. So we can build the sun. That's one way to do it. But on Earth, how do you create a fusion reaction?
Yeah. Well,
engineering-wise,
nature's fusion reactors are indeed the stars, and they are very hot in the center, and they reach the point where they release more energy from those reactions than they lose by radiation and transport to the surface and so forth. And that's a state of ignition. And that's what we have to achieve to give net energy. It's like lighting a fire. If you have a bundle of sticks and you hold a match up to it, and you see smoke coming from the sticks, but you take the match away and the sticks just fizzle out. That's not the reason they fizzled out. Is that yes, they were burning, there was smoke coming from them, but they were not ignited. But if you are able to take the match away and they keep burning and they are generating enough heat to keep themselves hot and hence keep the reactions going, that's chemical ignition. Well, what we need to do, what the stars do, in order to generate nuclear fusion energy is they are ignited. They are generated enough energy to keep themselves hot. And that's what we've got to do on Earth if we're going to make fusion work on Earth. But it's much harder to do on Earth than it is, in a star, because, we need temperatures of order tens of millions of degrees Celsius in order for the reactions to go fast enough to generate enough electricity to keep it, or enough energy to keep it going. And so if you've got something that's tens of millions of degrees Celsius, and you want to keep it all together and keep the heat in long enough to have enough reactions taking place, you can't just put it in a bottle, plastic or glass, it would be gone, in milliseconds. Mm-hmm. So you have to have some non-material mechanism of confining the plasma. In the case of stars, that non-material force is gravity. So gravity is what holds a star together. It's what holds the plasma in long enough for it to react and sustain itself by the fusion reactions. But on Earth, gravity is extremely weak. I mean, I don't mean to say we don't fall. Yes, we fall. But the mutual gravitational attraction of small objects is very weak compared with the electrical repulsion or any other force that you can think about on Earth. And so we need a stronger force to keep the plasma together, to confine it. And the predominant attempt at making fusion work on Earth is to use magnetic fields to confine the plasma. And that's what I've worked on for essentially most of my career, is to understand how we can and how best we can confine these incredibly hot gases, plasmas, using magnetic fields with the ultimate objective of releasing fusion energy on Earth and, generating electricity with it and powering our society with it.
Dumb question. So on top of the magnetic fields, do you also need the plastic water bottle walls, or is it purely magnetic fields?
Well, actually, what we do need walls. Those walls must be kept away from the plasma, because otherwise they'd be melted, or the plasma must be kept away from them, inside of them. But the main purpose of the walls is not to keep the plasma in, it's to keep the atmosphere out.
Oh.
So if we want to do it on Earth where there's air, we want the plasma to consist of hydrogen isotopes or other things, the things we're trying to react. And by the way, the density of those plasmas, at least in magnetic confinement fusion, is very low. It's maybe 1 million times less than the density of air in this room. So in order for a fusion reactor like that to work, you have to keep all of the air out and just keep the plasma in. So yes, there are other things, but those are things that are relatively easy. I mean, making a vacuum these days is technologically quite straightforward. We know how to do that, okay? What we don't quite know how to do is to make a confinement device that isolates the plasma well enough so that it's able to keep itself burning with its own reaction.
So maybe can you talk about what a tokamak is?
The Russian acronym from which the word tokamak is built just means toroidal magnetic chamber. So it's a toroidal chamber. A torus is a geometric shape which is like a donut with a hole down the middle. Okay, and so it's the meat of the donut. Okay, that's the torus, and it's got a magnetic field. So that's really all tokamak means. But the particular configuration that is very widespread and is the sort of best prospect, at least in the near term, for making fusion energy work, is one in which there's a very strong magnetic field the long way round the donut, around the torus. Mm-hmm. So you've got to imagine that there's this donut shape with an embedded magnetic field just going round and round the long way. The big advantage of that is that plasma particles, when they're in the presence of a magnetic field, feel strong forces from the magnetic field, and those forces make the particles gyrate around the direction of the magnetic field line. So basically, the particles follow helical orbits, following like a spring that's directed along the magnetic field. Well, if you make the magnetic field go inside this toroidal chamber and just simply go round and round the chamber, then because of this helical orbit, the particles can't move fast across the magnetic field, but they can move very quickly along the magnetic field. And if you have a magnetic field that doesn't leave the chamber, it doesn't matter if they move along the magnetic field. It doesn't mean they're going to exit the chamber. But if you just had a straight magnetic field, as for example, coming from a Helmholtz coil or a bar magnet, then you'd have to have ends. It would come to the ends of the chamber somewhere, and the particles would hit the ends, and they would lose their energy. So that's why it's toroidal, and that's why we have a strong magnetic field. It's providing a confinement against motion in the direction that would lead the particles to leave the chamber. It turns out that, and here we're getting a little bit technical, but it turns out that a toroidal field alone is not enough, and so you need more fields to produce true confinement of plasma, and we get those by passing a current as well through the plasma itself.
Or to make sure it stays on track.
Well, what that does is makes the field lines themselves into much bigger helices. And that,
interesting.
for reasons that are too complicated to explain, that clinches the confinement of the particles, at least in terms of their single particle orbits, so they don't leave the chamber.
And so when the particles are flying along this donut, the inside of the donut, are they? Where's the generation of the energy coming from? Are they smashing into each other?
Yeah, eventually. I mean, in a fusion reactor, there will be deuterons and tritons, and they will be smashing in. They will be very hot. They'll be 100 million degrees Celsius or something. So they're moving thermally with very large thermal energies in random directions, and they will collide with one another and have fusion reactions. When those fusion reactions take place, energy is released, large amounts of energy is released in the form of particles. One of the particles that's released is an alpha particle, which is also charged and is also confined. And that alpha particle stays in the donut and heats the other particles that are in that donut. So it transfers its energy to those, and it keeps them hot. There's some leaking of heat all the time, a little bit of radiation, some transport, and so forth. There's also a neutron released from that reaction. The neutron carries out 4/5 of the fusion energy, and that will have to be captured in a blanket that surrounds the chamber in which we take the energy, drive some kind of electrical generator from, thermal engine, gas turbine or something like that, and power the.
And you got energy. So where do we stand?
Where do we stand?
On getting this thing to be something that actually works, that generates energy.
Yep. Well, there have been experiments that have generated net nuclear energies or nuclear powers in the vicinity of, a few tens of megawatts for a few seconds. So that's, 10 megajoules. That's not much energy. It's a few donuts worth of energy. Okay.
Yeah.
Literal donuts.
Literal donuts. That's right.
But we have studied how well the tokamaks confine plasmas. And so we now understand in rather great detail the way they work. And we're able to predict what is going to be required in order to build a tokamak that becomes self-sustaining, that becomes essentially ignited or so close to ignited that it doesn't matter. And at the moment, at least if you use the modest magnetic field values, still very strong, but limited magnetic field values, you have to build a very big device. And so we are at the moment worldwide fusion research is at the moment in the process of building a very big experiment that's located in the south of France. It's called ITER, I-T-E-R, which means the way, or just means the International Tokamak Experimental Reactor, if you like. And that experiment is designed to reach this burning plasma state and to generate about 500 megawatts of fusion power for hundreds of seconds at a time. It'll still only be an experiment. It won't put electricity on the grid or anything like that. It's to figure out whether it works and what the remaining engineering challenges are. It's a scientific experiment. It won't be engineered to run round the clock and so on and so forth, which ultimately one needs to do in order to make something that's practical for generating electricity. But it will be the first demonstration on Earth of a controlled fusion reaction for long time periods.
Is that exciting to you?
It's been an objective that has in many ways motivated my entire career and the career of many people like me in the field. I have to admit, though, that one of the problems with ITER is that it's an extremely big and expensive and long time to build experiment. And so it won't even come into operation until about 2025, even though it's been being built for 10 years and it was designed for 30 years before that.
Right.
And so that's actually one of the big disappointments of my career, in a certain sense, which is that we won't get to burning fusion reaction until well past the first operation of ITER. And whether I'm alive or not, I don't know. But I certainly will be well and truly retired by the time that happens. And so when I realized maybe some years ago that that was going to be the case, it was a discouragement to me, let's put it like that.
But if we can try to look maybe in a ridiculous kind of way, look into 100 years from now, 200 years, 500 years from now, and we, there's folks like Elon Musk trying to travel outside the solar system.
Sure.
I mean, the amount of energy we need for some of the exciting things we want to do in this world, if we look, again, 100 years from now, seems to be a very large amount. So do you think fusion energy will eventually, sometime into your retirement, will be basically behind most of the things we do?
Look, I absolutely think that fusion research is completely justified. In fact, we should be spending more time and effort on it than we currently do. But it isn't going to be a magic bullet that somehow solves all the problems of energy. By the way, that's a generic statement you can make about any energy source, in my view. I think it's a grave mistake to think that science of any sort is suddenly going to find a magic bullet for meeting all the energy needs of society, or any of the other needs of society, by the way. And we can talk about that, I hope, later.
Sure.
Okay?
Yes, definitely.
But fusion is very worthwhile, and we should be doing it. And so my disappointment that I just expressed was, in a certain sense, a personal disappointment. I do think that fusion energy is a terrific challenge. It's very difficult to bring the energy source of the sun and stars down to Earth. This does contrast, in a certain sense, with fission energy. By contrast, fission energy, to build a fission reactor proved to be amazingly easy. We did it within a few years of discovering nuclear fission. People had figured out how to build a reactor and did so, during the Second World War.
Which is, by the way, fission is how the current nuclear power plants work.
Yeah. And so we have nuclear energy today because fission reactors are relatively easy to build. You've got to have what's hard is getting the materials, okay? And that's just as well, because if everyone could get those materials, there would be weapons proliferation and so forth. But it wasn't all that long after even the discovery of nuclear fission that fission reactors were built. And fission reactors, of course, operated before we had weapons. So I think nuclear power is obviously important to meet the energy challenges of our age. It is intrinsically completely CO2 emissions free. And in fact, the wastes that come from nuclear power, whether it's fission or fusion for that matter, are so moderate in quantity that we shouldn't really be worried about them. Yes, fission products are highly radioactive and we need to keep them away from people, but there's so little of them, it's that keeping them away from people is not particularly difficult. And so while people complain a lot about the drawbacks of fission energy, I think most of those complaints are ill-informed. We can talk about, the challenges and the disasters, if you like, of fission reactors. But I think fission, in the near term, offers a terrific opportunity for environmentally friendly energy, which in the world as a whole is rapidly being taken advantage of. China and India and places like that are rapidly building fission plants. We're not rapidly building fission plants in the US, although we are actually building 2 at the moment, 2 new ones. But we do still get 20% of our electricity from fission energy, and we could get a lot more.
So it's clean energy.
So it's clean energy.
Now again, the concern is there's a very popular HBO show on just came out on Chernobyl. There's the 3 Mile Island. There's Fukushima. This is the most recent disaster. So there's a kind of a concern of, nuclear disasters. Is that, well, what do you make of that kind of concern, especially if we look into the future of fission energy-based reactors?
Well, first of all, let me say one or two words about the contrast between fission and fusion, and then we'll come on to the question of the disasters and so forth. Fission does have some drawbacks, and they're largely to do with four main areas. One is, do we have enough uranium or other fissile fuels to supply our energy needs for a long time? The answer to that is we know we have enough uranium to support fission energy worldwide for thousands of years, but maybe not for millions of years, okay? So that's resources. Secondly, there are issues to do with wastes. Fission wastes are highly radioactive, and some of them are volatile. And so, for example, in Fukushima, the problem was that some fraction of the fission wastes were volatilized and went out as a cloud and polluted areas with cesium-137, strontium-90, and things like that. So that's a challenge of fission. There's a problem of safety beyond that, and that is that in fission, it's hard to turn the reactor off. When you stop the nuclear reactions, there is still a lot of heat being liberated from the fission products. And that is actually what the problem was at Fukushima. The Fukushima reactors were shut down the moment that the earthquake took place. And they were shut down safely. What then happened after that at Fukushima was, there was this enormous tidal wave, many tens of meters high, that came through and destroyed the electricity grid feed to the Fukushima reactors. And their cooling was then turned off. And it was the afterheat of the turned off reactors that eventually caused the problems that led to release. And so that's a safety concern. And then finally, there's a problem of proliferation. And that is that fission reactors need fissile fuel, and the technologies for producing and enriching and so forth the fuels can be by bad actors to generate the materials needed for a nuclear weapon, and that's a very, very serious concern. So those are the four problems. Fusion has major advantages in respect of all of those problems. It has more longer-term fuel resources. It has far more benign waste issues. The radioactivity from fusion reactions is at least 100 times less than it is from fission reactions. It has essentially none of this afterheat problem because it doesn't produce fission products that are highly radioactive and generating their own heat when it's turned off. In fact, the hard part of fusion is turning it on, not turning it off. And finally, you don't need the same fission technology to make fusion work, and so it's got terrific advantages from the point of view of proliferation control. So those are four main issues which make fusion seem attractive technologically, because they address some of the problems of fission energy. I don't mean to say that fission energy is overwhelmingly problematic, but clearly there have been catastrophes associated with fission reactors. Fukushima actually is, I think, in many ways often overstated as a disaster, because after all, nobody was killed by the reactors, essentially, zero. And that's in the context of a disaster, a tsunami that killed between 15 and 20,000 people more or less instantaneously. So, in the scale of risks, one should take the view that, in my estimation, that fission energy came out of that looking pretty good. Okay, Of course, that's not the popular conception. Okay.
Yeah, it's kind of, I mean, with a lot of things that threaten our well-being, we seem to be very bad users of data. We seem to be very scared of shark attacks and not at all scared of car accidents and this kind of miscalculation. And I think from everything I understand, nuclear energy, fission-based energy goes into that category. It's one of the safest, one of the cleanest forms of energy.
Right.
And yet the PR, whoever does the PR for nuclear energy is not has a hard job ahead of them at the moment.
Well, I think part of that is their association with nuclear weapons.
Right.
Because when you say the word nuclear, people don't instantly think about nuclear energy; they think about nuclear weapons, and so there is, perhaps a natural tendency to do that. But yes, I agree with you. People are very poor at estimating risks, and they react emotionally, not rationally, in most of these situations.
Can we talk about nuclear weapons just for a little bit? So fission is the kind of reaction that's central to the nuclear weapons we have today.
That's what sets them off.
That's what sets them off. So if we look at the hydrogen bomb, maybe you can say how these different weapons work.
So the earliest nuclear weapons, the nuclear bombs that were dropped on Japan, et cetera, were pure fission weapons. They used enriched uranium or plutonium, and their energy is essentially entirely derived from fission reactions. But it was early realized that more energy was available if one could somehow combine a fission bomb with fusion reactions, because the fusion reactions give more energy per unit mass than fission reactions, and this was called the super. You might have heard of the expression the super, or more simply, hydrogen bombs. Okay, bombs which use isotopes of hydrogen and the fusion reactions associated with them.
But like you said, it's hard to turn on.
It's hard to turn on because you need very high temperatures and you need confinement of that long enough for the reactions to take place. And so a bomb, actually, a thermonuclear bomb or a hydrogen bomb, has essentially a chemical implosion which then sets off a fission explosion, which then sets off and compresses hydrogen isotopes and other things, which I don't know because I've never had a security clearance. Okay, so I can't betray any secrets about weapons because I've never been party to them, but because I know a lot about this problem, I can guess. Okay, and sets off fusion reactions in the middle. Okay, so that's basically, it's that sequence of things which produce these enormous, multi-megaton bombs that have very large yields. And so fusion alone can't get you there. It is actually possible to set off or to try to set off little fusion bombs alone without the surrounding fission explosion. And that is what is called laser fusion. So another approach to fusion, which actually is mostly researched in the weapons complex, the national labs and so forth, because it's more associated with the technologies of weapons, is inertial fusion. So if you decide instead of trying to make your plasma just sit there in this torus, in the tokamak, and be controlled steady state with a magnetic field, if you're willing to accept that I'll just set off an explosion, okay, and then I'll gather the energy from that somehow. I don't quite know how, but let's not ask that question too much. Then it is possible to imagine generating fusion alone explosions. And the way you do it is you take some small amount of deuterium tritium fuel, you bombard it with energy from all sides, and this is what the lasers are used for, extremely powerful lasers, which compresses the pellet of fusion and heats it, it compresses it to such a high density and temperature that the reactions take place very, very quickly. And in fact, they can take place so quickly that it's all over with before the thing flies apart. Okay?
Wow.
And that
So
is
heat it up really fast.
that is inertial fusion. Okay?
Is that useful for energy generation for
No,
outside?
not yet. I mean, there are those people who think it will be, but you may have heard of the big experiment called the National Ignition Facility, which was built at Livermore starting in the late 1990s and has been in operation since around about 2010. It was designed with the claim that it would reach ignition, fusion ignition, in this pulsed form where the reactions are got over with so quickly before the whole thing flies apart. It didn't actually reach ignition, and it doesn't look as if it will, although, we never know. Maybe people figure out how to make it work better. But the answer is, in principle, it seems possible to reach ignition in this way, maybe not with that particular laser facility.
Are you surprised that we humans haven't destroyed ourselves, given that we've invented such powerful tools of destruction? Like, what do you make of the fact that for many decades we've had nuclear weapons now? Speaking about estimating risk, at least to me, it's exceptionally surprising. I was born in the Soviet Union, that big egos of the big leaders, when rubbing up against each other, have not created the kind of destruction everybody was afraid of for decades.
Well, I must say I'm extremely thankful that it hasn't. I don't know whether I'm surprised about it. I've never thought about it from the point of view of, is it surprising that we've avoided it? I'm just very thankful that we have. I think that there is a sense in which cooler heads have prevailed at crucial moments. I think there is also a sense in which, mutually assured destruction has in fact worked as a policy to restrain the great powers from going to war. And in fact, the fact that we haven't had a world war, since the 1940s is perhaps even attributable to nuclear weapons in a kind of strange and peculiar way. But I think humans are deeply flawed and sinful people, and I certainly don't feel that we're guaranteed that it's going to go on like this.
And we'll talk about the sort of the biggest picture view of it all. But let me just ask, in terms of your worries of, if we look 100 years from now, we're in the middle of what is now a natural pandemic that, from the looks of it, fortunately is not as bad as it could have possibly been. If you look at the Spanish flu, if you look at the history of pandemics, if you look at all the possible pandemics that could have been, that folks like Bill Gates are exceptionally terrified about, I know many people are suffering, but it's better than it could have been. So now we're talking about nuclear weapons in terms of existential threats to us as sinful humans. What worries you the most? Is it nuclear weapons? Is it natural pandemics, engineered pandemics, nanotechnology? In my field of artificial intelligence, some people are afraid of killer robots and
robots. Yeah.
Do you think in those existential terms? And do any of those things worry you?
I am certainly not confident that my children and grandchildren will experience the benefits of civilization that I have enjoyed. I think it's possible for our civilizations to break down catastrophically. I also think that it's possible for our civilizations to break down progressively. And I think they will if we continue to have the explosion of population on the planet that we currently have. I mean, it's quite wrong to think of our problems as mostly being CO2. If we can just solve CO2, then we can go on having this, continually expanding economy everywhere in the world. Of course you can't do that, okay? I mean, there is a finite bearing capacity of our planet.
On the resources of our planet.
On the resources of our planet. And we can't continue to do that. So I think there are lots of technical reasons why a continually expanding economy and civilization is impossible. And that therefore, actually, I'm as much nervous about the fact that our population is 8 billion or something right now worldwide, as I am about the fact that a few million people would be killed by COVID-19. I mean, I don't want to be callous about this, but from the big picture, it seems like that's much more of a problem. Overpopulation, people not dying, is ultimately more of a problem than people dying. So that probably sounds incredibly callous to your listeners, but I think it's simply, a sober assessment of the situation.
Is there ways from the way those 8 billion or 7 billion or whatever the number is live that could make it sustainable? Because you've kind of implied there's a kind of we have, especially in the West, this kind of capitalist view of really consuming a lot of resources. Is there a way to, if you could change one thing or a few things, what would you change to make this life, make it more likely that your grandchildren have a better life than you?
Well, okay, so let's talk a bit about energy, because that's something I know a lot about, having thought about it most of my career. In order to reach a steady state CO2 level, okay, that's acceptable in terms of global climate change and so on and so forth, we need to reduce our carbon emissions by at least a factor of 10 worldwide, okay? What's more, the average energy consumption, and hence CO2 emission, of people in the world is less than a tenth of what we, per capita, than what we have in the West, in America and Europe and so forth. So if you have in mind some utopia in the future where we've reached a sustainable use of energy, and we've also reached a situation in which there's far less inequity in the world, in the sense that people share the energy resources more uniformly, then what that is equivalent to would be to reduce the CO2 emissions in Western economies, not by a factor of 10, but by a factor of 100. In other words, it has to go down to 1% of what it is now, okay?
Yeah.
So, when people talk about, let's use natural gas because, maybe it only uses 60% of the energy of coal. It's complete nonsense. That's not even scratching the surface of what we would need to do. So, is that going to be feasible? I very much doubt it. And therefore, I actually doubt that we can reach a level of energy, of fossil energy use that is 1% of the current use in the West, without totally dramatic changes either in, our society, our use of energy and so forth, which actually, of course, is much of that energy is used for producing food and so on and so forth. So it's actually not so obvious that we can cut down our energy usage by that factor. Or we've got to reduce the human population.
So you run up against that number that's increasing still. And you don't think there could be
that's depressing?
No, it's not. It's not depressing. It's difficult, like many truths are. Do you have a hope that there could be a technological solution?
In short, no. There is no technological solution to, for example, for population control. I mean, we have the technology just, to prevent ourselves bearing children. That's not a problem. Technology's in, okay? Solved. The challenge is society. The challenge is human choices. The challenge is almost entirely human and sociological, not technology. And when people talk about energy, they think that there's some kind of technological magic bullet for this, but there isn't, okay? And there isn't for the reasons I just mentioned. Not because it's obvious there isn't, but actually there isn't. And in any case, it's true of energy, it's true of pollution, it's true of human population, it's true of most of the big challenges in our society are not scientific or technological challenges. They're human, sociological challenges. And that's why I think it's a terrible mistake, even for folks like me who work at, the high temple of science and technology in America and maybe in the galaxy.
Yeah.
I mean, it's
MIT.
It's at MIT.
Best university in the world.
It's a terrible mistake if we give the impression that technology is going to solve it all. Technology will make tremendous contributions, and I think it's worth working on it. But it's a disaster if you think it's going to solve all of our problems. And actually, I've written a whole book about the question of scientism and the overemphasis on science, both as a way of solving problems through technology, but also as a way of gaining knowledge. I think it's not all of the knowledge there is either.
Yeah, I think that book and your journey there is fascinating. So maybe we can go there. Can you tell me about on a personal side, the personal journey of your faith, of Christianity and your relationship with God, with religion in general?
Yeah, in my latest book, Can a Scientist Believe in Miracles? I give I devote most of the first chapter to telling how I became a Christian, why I became a Christian. I didn't grow up as a Christian,
which is fascinating. I mean, you didn't grow up as a Christian, so you've discovered the beauty of God and physics at the same time.
That's a very poetic way of putting it, but yes, I would accept that. I became a Christian when I was an undergraduate at Cambridge University. I had gone to a school in which there was religion, kind of was part of the society. There were prayers and at the daily gathering of the students, the assembly of the students. But I didn't really believe it. I just sort of went along with it, and it wasn't particularly aggressive or benign. It just sort of was there. But I didn't believe it. I didn't make much sense to me. But I came across Christians from time to time. And when I went to Cambridge University, two of my closest friends, it turned out, were Christians. And I think that was the most important influence on me, that here were two people who were really smart, like me. I'm giving you my my impression.
The way you felt at the time. Yeah.
The way I felt at the time, and they thought Christianity made sense and testified to its significance in their lives, and so that was a very important influence on me. And ultimately, I mean, the reason I didn't see Christianity as some kind of great evil, the way it's sometimes portrayed by the radical atheists of this century. I mean, I think that's nonsense. So I think there were certain attractive things. If you go to a university like Cambridge, you're surrounded by Western culture, from about the 15th century onwards, and that's saturated with Christian art and architecture and so forth. And so it's hard not to recognize that Christianity is, in fact, the foundation of Western society and Western culture, Western civilization. So I mean, maybe I was in that sense favorably disposed towards Christianity as a religion, but as a personal faith, it didn't mean anything to me. But I became convinced really of two things. One is that the evidence for the resurrection of Jesus Christ is actually rather good. I mean, it's not a proof. It's not kind of some kind of scientific demonstrate or mathematical demonstration, but it's actually extremely good. It's not scientific evidence by and large. It's historical evidence.
Historical evidence, yeah.
So that was one thing. And the other thing that came to me when I was at Cambridge, it became clear that Christianity ultimately is not some kind of moral theory or philosophy or something like that. It is, or at least it claims to be, a personal relationship with God, which is made possible, by what Jesus did on the cross and his life and his teaching, and it's a personal call to a relationship with God, and that I'd never really thought of it in those terms when I was younger, and that thought became attractive to me. I mean, I think most people find the person of Christ and his teachings, compelling in a certain sense.
What do you mean by personal? Do you mean personal for you, like a relationship, like it's a meditative, like you specifically, you, Ian, have a connection with God, and then the other side, you say personal with the actual body, the person of Jesus Christ. So all of those things, what do you mean by personal connection, and why that was meaningful?
Well, so as a
and sorry for the stupid questions.
No, it's okay, no problem. As a Christian, I believe that I have a relationship with God, which is best expressed by saying that it's personal. And that comes about because, Jesus, through his acts, has reconciled me with God, me a sinner, me someone full of sins, of failings, of ways in which I don't live up to even my own ideals, let alone the ideals of a holy God, have been reconciled to the creator of everything. And so Christians, myself included, believe that prayer is, in a certain sense, a connection with God. And there are times when I have felt, that God spoke to me. I don't mean necessarily orally in words, but showed me things or enlightened me or inspired me in ways that I attribute to him. So I see it as a two-way relationship in a certain sense. Of course, it's a very asymmetrical relationship, but nevertheless, Christians think that it's a two-way street. We're not just talking into the air when we say we are going to pray for someone.
In this two-way communication, is there a way that you could try to describe on a podcast what is God? What is God like, in your view? If you try to describe, is it a force? Is it for you intellectually? Is it a set of metaphors that you use to reason about the world? Is it kind of a computer that does some computation? That's an infinitely powerful computer, or is it like Santa Claus, a guy with a beard on the cloud? Like I don't mean what God actually is. I mean, in your limited cognitive capacity as a human, what do you find helpful for thinking of what God actually looks like? What is God?
Well, let me start by saying none of the above, okay? I mean, clearly God, in the Christian God, the God of Abraham, Isaac, and Jacob, etc., it is not any of those things, because all of those things you just mentioned are phenomena or entities in the created world.
Right.
And the most fundamental thing about monotheism, as Abraham and Moses and so forth handed it down, is that God is not an entity within the creation, within the universe, that God is the creator of it all. And that's what Genesis, first two chapters of Genesis, is really about. It's not about telling us, how God created the world. It's about telling us and telling the early Hebrews that God created the world, okay? And that therefore he is not, simply an entity within it. On the other hand, our finite minds have a pretty hard time encompassing that.
Right. Yeah.
So one has to therefore work in terms of metaphors and images and so forth. And I think we would know very little about who God is if we were simply left to our own devices. If we were just here you are, you're in the universe, try to figure out who made it and so forth. Well, philosophers think they can do a little bit of that, maybe, and theologians think that they can do a little bit more. But But Christians think that God has actually helped us along a lot by revealing himself. And we say that he's revealed himself supremely in the person of Jesus Christ. And so, when Jesus says to his disciples, if you've seen me, you've seen the Father, then that is, in a certain sense, a watchword for answering this question for Christians. It is that supremely, if we want to help ourselves understand who God really is, we look to Jesus. We look to what he did. We look to what he said, and so forth. And we believe that he is one with the Father, and that's why we believe, in the Trinity. I mean, it's basically because that revelation is extremely central to Christian belief and teaching.
So in that sense, through Jesus, there was that's kind of a historical moment that's profound, that's really powerful. But do you also think that God makes himself seen in less obvious ways in our world today?
Absolutely. I mean, it's certainly been the outlook of Jews and Christians throughout history that God is seen in the creation. That when we look at the creation, we see to some extent the wonder, the majesty, the might of the person or the entity, but the person who created it. And that's a way in which scientists, particularly, have over the ages, and certainly over most of the last 5 centuries since the scientific revolution, scientists have seen, in a certain sense, the hand of God in creation. I mean, this leads us perhaps to a different discussion, but I mean, it's remarkable to me how influential Christianity and religion generally has been in science.
Yeah, most of the scientists through history, as you described, I mean, God has been a very big part of their life and their work.
Certainly
and their thinking.
Up until the beginning of the 20th century, that was the case.
So maybe this is a good time can you tell me what scientism is?
Yeah, I mean, the short answer is that by scientism, we mean the belief that science is all the real knowledge there is. I mean, that's a shorthand. There are lots of different facets of it, and which one can explore. And the book in which I explored it most thoroughly was actually an earlier book called Monopolizing Knowledge. And the purpose of that title is to draw attention to the fact that in our society as a whole, particularly in the West today, we have grown so reliant on science that we tend to put aside other ways of getting to know things. And so, of course, at MIT, we are focused on science, and we do focus on it very much. But the truth is that there are many ways of getting to know things in our world, know things reliably in our world, and a lot of them are not science. So scientism, in my view, is a terrible intellectual error. It's the belief that somehow the methods of science, as we've developed them with experiments, and in the end, it relies particularly upon reproducibility in the world and on a kind of clarity that comes from measurements and mathematics and related types of skills. Those, powerful though they are for finding out about the world, are not all the knowledge, do not give us all the knowledge we have, and there's many other forms of knowledge. And the illustration that I usually use to try to help people to think about this is to say, well, look, let's think about human history. I mean, to what extent can human history be discovered scientifically? The answer is essentially it can't. And the reason is because human history is not reproducible. You can't do reproducible experiments or observations and go back and try it over again. It's a one-off thing. The history is full of unique events, and so you can't hope to do history using the methods of science.
Yeah, I mean, in some sense, history is a story of miracles. I mean, they don't have to to do with God. It's just
uniqueness is anyway, unique events. That's
unique
sure.
events, and that science doesn't like that because it's unique events by their very definition are not reproducible. Can I ask sort of a tricky question? I don't even know what atheist or atheism is, but is it possible for somebody to be an atheist and avoid slipping into scientism?
Oh yeah, absolutely. I mean, these are two separate things. Okay, I'm quite sure there are many people who don't believe in God and yet recognize that there are many different ways we get knowledge. Some is history, some is sociology, economics, politics, philosophy, art history, language, literature, etc., etc. There are many people who recognize those disciplines as having their own approaches to epistemology and to how we get knowledge, and valuing them very highly. I don't mean to say that everyone, who's an atheist automatically, subscribes to the scientific viewpoint. That's not true. But it's certainly the case that many of the arguments, in fact, most of the arguments of the aggressive atheists of this century, people are sometimes called new atheists, although they're actually rather old. Most of their arguments are rather old, are drawing heavily on scientism. So when they say things like, there's no evidence to support Christianity, okay? What they are really focusing on is saying that Christianity isn't proved, or the evidence for Christianity is not science. Okay, science doesn't prove it. Right. And if you read their books, that's what you find they really mean is science doesn't lead you necessarily to believe in a creator God or in any particular religion. I accept that. That's not a problem to me. Because I don't think that science is all the knowledge there is, and I think there are other important ways of getting to know things, and one of them is historical, for example. And I mentioned earlier that I became persuaded, and I still am persuaded, that the historical evidence for the resurrection is very persuasive. Again, it's not proof or anything like that, but it's pretty good evidence. Okay.
Yeah, I talked to Richard Dawkins on this podcast, and I saw you debate with Sean Carroll. So I understand this world. It makes me very curious. Maybe let me ask sort of another way. My own kind of worldview. Maybe you can help, as by way of therapy, understand. Because you've kind of said that there's other ways of knowing. What about if I kind of sit here and am cognizant of the fact that I almost don't know anything? So sort of I'm sitting here almost paralyzed by the mystery of it all. And it's not even, when you say there's other ways of knowing, it feels almost too confident to me, because when I listen to beautiful music or see art, there's something there that's beyond the reach of scientism, I would say, sort of beyond the reach of the tools of science. But I don't even feel like that could be as an actual tool of knowing. I just don't even know where to begin, because it just feels like we know so little. Like if we look even 100 years from now, when people look back to this time, humans look back to this time, they'll probably laugh at how little we knew, even 100 years from now. And if we look at 1,000 years from now, hopefully we're still alive, or some version of ourselves, or AI version of ourselves are still alive. They'll certainly laugh at the absurdity of our beliefs. So what do you... so you don't seem to be as paralyzed by how little we know. You confidently push on forward. But what do you make of that sense of just not knowing, of the mystery?
First of all, we need to be modest or humble, if even, about what we know. I accept that, and I certainly think that's true. Not simply because in the future we'll know more science and there will be more powerful ways of finding out about things, but simply because, sometimes we're not right. We're wrong, okay? in what we think we know. So that's crucial, but it's also a very Christian outlook. That kind of humility is what Jesus taught. So I don't know whether this was in the back of your mind when you were thinking about this, but it's often the case that people of religious faith are accused of being dogmatists, okay? And there is a sense in which dogma, teaching, accepted teaching, is part of religions, okay? But I don't think that necessarily that leads one to blind dogmatism. And I certainly don't think that faith, we can talk about this later if you like, but I certainly don't think that faith means thinking you know something and not listening to counter arguments, for example. So I think that's crucial.
Yeah. What does faith mean to you? What does it feel like? What does it actually how do you carry your faith in terms of the way you see the world?
Well, I think faith is very often misunderstood in our society at the moment because it's often portrayed as being nothing other than believing things you know ain't true,
Yeah.
or believing things that are not proven. Okay, and faith does have a strand which is to do with basically believing in concepts or propositions. But actually, the word faith is much broader than that. Faith also means, trusting in something, trusting in a person, or trusting in a thing, the reliability of some technology, for example. That's equally part of the meaning of the word faith. And there's a third strand to the meaning of the word as well, and that is loyalty. So I have faith in my wife, and I try to act in faith towards her, and that's a kind of loyalty. And so those three strands are the most important strands of the meaning of faith. Yes, belief in propositions that we might not have full proof about, or maybe we have very little proof about, but it's also trust and loyalty. And actually, in terms of the Christian faith, Christians are far more called to trust and loyalty than they are to belief in things they don't have proof of. Okay, but the critics of religion generally tend to emphasize the first one and say, well, you believe things for which you have no evidence. Okay, that's what they think faith is. Well, yeah, there is a sense in which everybody has to live their lives believing or making decisions in situations when they don't have all the proof or evidence or knowledge that enables you to make a completely rational or well-informed or prudent decision. We do this all the time. My drive down here, I nearly took a wrong turning, and I thought, which way do I go? Do I keep going straight on? And so my voice came out of me, think, go straight, okay? So you have to make decisions, and sometimes you don't have a navigation system telling you what to do. You just have to make that decision with insufficient evidence. And you're doing it all the time as a human, and that's part of being sentient. And so that kind of action and belief on the basis of incomplete evidence is not something that I feel uncomfortable doing, or that somehow my Christian commitments have forced me to do when I wouldn't have had to have done it otherwise. I would have had to do it anyway. And so, there's a sense in which I think it's important to see the breadth of meaning of faith and to recognize that, certainly in the case of Christianity, it's trust and loyalty that the key themes that we're called to.
And I mean, another interesting extension of that you speak to is kind of loyalty is referring to a connection with something outside of yourself.
Yeah.
So I think you've spoken about like existentialism or even just atheism in general as as leading naturally to an individualism, as a focus on the self, and ideas that maybe the Christian faith can instill in you is allowing you to sort of look outside of yourself. So connection, I mean, loyalty fundamentally is about other beings, other beings. And I mean, I think, I don't know what it is in me, but I'm very much drawn to that idea. And I think humans in general are drawn to that idea. You can make all kinds of evolutionary arguments, all that kind of stuff. But people always kind of tease me because I talk about love a lot. And I mean, there's a lot of non-scientific things about love, right? Like, what the heck is that thing? Why do we even need that thing? It seems to be an annoying burden that that we get so much joy in life from a connection with other human beings, deep, lasting connections with human beings. Same thing with loyalty. Why do we get so much value and pleasure and strength and meaning from loyalty, from a connection with somebody else, going through thick and thin with somebody else, going through some hard times? I mean, some of the closest friends I have is going through some rough times together, and that seems to make life deeply meaningful. What is that? So
that resonates with me, and I would affirm it. I think just to correct an implication that you made, I don't think it's necessarily the consequence of atheism that we lose track of those kinds of things. I mean, I think that atheists can be loyal, okay, if you like. Right. The question more often comes up in the context of, where does morality come from? Mm. And loyalty, I think, and duty are related to one another. If we have loyalty to someone, then we have a duty to them, okay, as well. And I think that insofar as we see ourselves as having any kinds of duties or moral compulsions with respect to our relationships to other people, I think it's a question that always arises. Well, where do these come from? And there are various approaches that people have towards deciding what makes ethics or morality moral. Okay, but I do think it's the case that it's very hard to ground morality in any kind of absolute way or persuasive way in mere human relationships. And so it's certainly the case that in Christianity, there is a sense in which morality and the morality of morals comes from a transcendent place, from a transcendent deity, and that we ground the compelling force of morals on God more than we do on individuals. Because after all, if you've got nothing but other people, why should you treat your neighbor well? Why shouldn't you defraud your neighbor if it's good for you? Well, you can construct all kinds of arguments, and some of them are, obviously arguments that are commonplace in religion too. You should do as you would be done by, and all this kind of thing. Right. But none of that seems any more than mere pragmatism to most people. Okay, and so that's one of the things that Nietzsche, amongst others, really identified. If God is dead, if the idea of God as grounding our moral behavior is no longer viable in the West, which Nietzsche thought that it wasn't, okay, then what does ground it? And he had no good answer for it. In fact, he claimed there was no answer, but then he couldn't live with that. And so he invented the idea of the Übermensch, this superior human being, okay? And this was a different way of trying to ground morality, not a very successful one. You could argue that it's a forerunner of the sort of racism of Hitler's regime and so forth that we've in the West thankfully shied away from in the past half or 3/4 of a century. But I think it is the case that Christianity gives me a basis for my moral beliefs that is more than mere pragmatism.
Yeah, but there is so stepping outside of all of that, there does seem to be a powerful stabilizing, like we humans are able to hold ideas together, like in a distributed way, outside of whether God exists or not, or any of that. Just our ability to kind of converge together towards a set of beliefs, sometimes into tribes. It's kind of I don't know if it's inherent to being human beings. I hope not, because now if I look on Twitter, and there's the red team and the blue team, right? It's almost like it's some kind of TV show that we're living in, that people get into these tribes and they hold a set of beliefs that sometimes don't. I mean, they are beliefs for the sake of holding those beliefs, and we get this intimate connection between each other for sharing those beliefs. And we spoke to the things about loyalty and love, and that's the thing that people feel inside the tribe. And it seems very human that within that tribe, those beliefs don't necessarily always have to be connected to anything. It's just the fact that, I've did sports my whole life. And whenever you're on a team, the bond you get with other people on the team is incredible. And the actual sport is often the silliest. I mean, I don't play ball sports anymore, but when I played like soccer or tennis, I mean, all those sports are silly, right? You're playing with a little ball, but there's the bond you get is so deeply meaningful. So it's interesting to me on the sociological level that it's possible to me, whatever the beliefs of religion is, whatever they're actually grounded in, they might be. They might have a power in themselves.
I think there is tribalism everywhere, and I think tribalism in the US at the moment is rather difficult to bear from my point of view. And it's, I think, fed by the internet and social media and so forth. But historically, tribalism has been a trait and remains a trait in humans. The genius of Christianity is that it supersedes tribalism. I mean, yes, when the Hebrews thought about Yahweh, initially they thought about him as their tribal deity, just like the tribal deities round about them. And so, and yet from, early on in Hebrew history, the crucial thing that Yahweh came to mean, or I would say revealed of himself to them, was that he wasn't just a tribal deity. He was the God that created the whole thing. And if he is the God of the whole thing, then he's not just the God of the Hebrews, or in the case of, Americans, God is not just the God of Americans, he's the God of everybody, okay? And that is in a way, the most amazing transcending of tribal loyalties. And one of the crucial, occasions in the New Testament, when the Holy Spirit comes at Pentecost, the apostles and the disciples speak in other tongues, and there are people from all the countries, round about, hear them in their own languages. And so, whether you take that as factual or not, that is a statement of the transcendent aspects of Christianity, or the claimed transcendent aspects of Christianity, that it transcends culture. And that's certainly something which I find appealing.
When I kind of touch on this topic in my own mind, one of the hardest questions is why is there suffering in the world? Do you have a good answer?
Well, I have some answers, but you're right that it is one of the toughest questions. The problem of pain, or the problem of suffering, or the problem of theodicy, as theologians call it, is probably one of the toughest. I think it's important to say that there are certain types of answers to this question, but there are aspects of this question to which there is no intellectual answer that is going to satisfy. And the fact of the matter is, when I'm speaking to an audience, let's say at some kind of lecture, I can be sure that there are people in that audience who are either personally suffering, they've got illness, they've got pains, maybe they're facing death, or someone in their family is in similar sorts of situations. So suffering is a reality, and there is nothing that I can say that is going to solve their feeling of agony and angst and maybe despair in those types of situations. There is really only one thing that I think humans can do for one another in those kinds of situations, and that is simply to be there alongside your friend or your colleague or whoever, family member or whoever it might be. And that's the only really sense in which we can give comfort. If we try to give intellectual solutions to these problems, we're going to be like the comforters that were in the book of Job in the Bible, who brought no comfort to Job himself with their intellectual answers. But if they had been there, and some of them were there, they sat alongside, that is some level of comfort. And after all, that's the meaning of the word compassion. It means to suffer alongside of somebody. And I would say, first off, what does a Christian say about suffering? The first thing a Christian should say is compassion is all that really counts. And what's more, we say that God has acted in compassion towards us. That is to say, he has suffered with us in the person of Jesus Christ. And when we see the passion of Jesus, we recognize that God takes suffering deadly seriously, has taken it so seriously that he's been willing to come and be a part of his creation in the person of Jesus Christ and suffer death, the most horrible death on the cross, for our benefit. So that's one side of suffering. But the question, the philosophical question remains, surely if God is good, and God is omnipotent, benevolent, why doesn't he take away all the suffering? Why doesn't he cause miracles to occur that will take away all this suffering? I think there are some good answers to that question in the following sense, that, we live in a world where the consistency of the world is an absolutely crucial part of it. The fact that our world behaves reproducibly in the main is absolutely essential for the integrity of our lives. Without it, we wouldn't exist, okay? And so there is a sense in which the integrity of creation calls for there being consistent behavior, which, these days we think of as being the laws of nature, okay? Right. And so the consistent behavior of nature is very, very important. And it's what enables us to be what we are. And if you're calling upon God in your critique of why isn't this benevolent creator, fixing things, one answer is he's fixed things in a certain sense to have an integrity in them. And that integrity is the best thing. It's the way we have our existence. It's the way we live and move and have our being. And, if you want something different, you've got to show that there is a way in which you could invent a world that is better, that it has the integrity that we need to exist, okay? And to be able to think and love and be, but you were going to do it better. And the atheists think that maybe they have got a better idea. But if they thought about it a bit more carefully, they'd realize no one has put forward a better idea. Okay.
So another way to say that, is that suffering is an integral part of this, of of a consistent existence. So
I think that,
sort of in a philosophical sense, the full richness and the beauty of our experience would not be as beautiful, would not be as rich, if there was no suffering in the world. Is that possible?
well, I think you said two different things that aren't exactly the same. One is that suffering is an integral part of our experience. That might be considered a challenge to certain types of Christian theology or even Jewish theology. In other words, Christians talk about the fall and talk about Adam and Eve in the garden and have a vision of there being some kind of perception from or perfection from which we have fallen. And I think there is a perfection from which we've fallen. But I don't think that perfection is some kind of physical perfection. In other words, I don't subscribe personally to the view that some Christians do, that there was some state prior to the fall in which death did not occur. I don't think that that's consistent with science as we know it. And I think that death, for example, has been part of the biological world and the universe as a whole from billions of years ago. So just to be clear about that, I on the other hand, I do so. If that's the case, then certainly in that sense, at the very least, suffering, or at least death, okay, is part of the biological existence. And that probably seems so completely obvious to somebody who, is au fait with science, whether they're a scientist or not.
Well, so, and I apologize if I'm interrupting, but it's the obvious reality of our life today. But there's a lot of people, I think it's currently in vogue. I've talked to quite a few folks who kind of see as the goal of many of our pursuits as to extend life indefinitely. A sort of, a dream for many people is to live forever. But in the technological world, in the engineering world, in the scientific world, I mean, that's the big dream. To me, it feels like that's not a dream. I certainly would like to live forever. Like that's the initial feeling, the instinctual feeling, because life is so amazing. But then, if you actually kind of like you've presented it, if you actually live that kind of life, you would realize that that's actually a step backwards. That's a step down from the experience of this life. In my sense, that death is an essential part of life, essential part of this experience, death of all things. So the fact that things end somehow, and the scarcity of things somehow create the beauty of this experience that we have.
Yeah, transhumanism doesn't look very attractive to me either, but it also doesn't look very feasible. But that's a whole big topic that I'm not exactly an expert. But I'll say, I'm of a certain age where my mortality is more pressing or more obvious to me than it once was. Okay, and I don't dread that. I don't see that as, in a certain sense, even the enemy. Okay,
you're not afraid of death?
Well, I'm afraid of lots of things in a conceptual way, but it doesn't keep me awake at night. Okay. I think, like most people, I'm more afraid of pain than I am of death. So I don't want to put myself forward as some kind of hero that doesn't worry about these things. That's not true. But I do think, and maybe this is part of my Christian outlook, that there is life beyond the grave. But I don't think that it's life in this universe or in this, certainly not in this body, and maybe not in a certain sense in this mind. I mean, Christian belief in the afterlife is that we will be resurrected. We will be, in a certain sense, be with God. I don't know what that means, and I don't think anybody else really quite knows what that means. But there are lots of ways that over history, people, artists and writers and so forth, have pictured it. And these are all perhaps some of them helpful ways of thinking about it.
Do you think it's possible to know what happens after we die?
I don't think we find out by near-death experiences or those kinds of things, but I think that that we have sufficient. I feel I have sufficient information, if you like, in terms of God's revelation, to be confident that I will go somewhere else. Okay, but it won't be here. And to me, the aspirations of transhumanism are horrific. I mean, I think it would be a nightmare, not a dream, a nightmare, to be somehow downloaded into a computer and live one's life like that. Because it completely discounts the integrity of our bodies as well as our minds. I mean, we aren't just disembodied minds. It would not be me that was in the computer. It would be something else if that kind of download were possible. Of course, it isn't possible, and it's a very long way from being possible. But, amazing things happen, so we shouldn't be too certain.
So this is a place that, again, maybe taking a slight step outside, we're philosophizing a little bit. Let me ask you about human level or superhuman level intelligence, the artificial intelligence systems. What do you make from almost a religious or a perspective that we've been talking about of the special aspect of human nature, of us creating intelligence systems that exhibit some elements of that human nature? Is that something, again, like we were talking about with transhumanism, there's a feasibility question of how hard is it to actually build machines that are human level intelligence or have something like consciousness or have all those kinds of human qualities. And then there's do we want to do that kind of thing? So on both of those directions, what do you think?
Well, okay. So, since your podcast is called AI, I don't want to offend too many of your listeners out there. But I think one should be a little bit more modest about one's claims for AI than have typically been the case.
Yeah.
I think that actually a lot of people in AI are somewhat chastened, and so there are more modest claims than are common with the transhumanists and so forth. And, I used to play chess when I was a kid. I was pretty good at it, okay? I won competitions and so on and so forth. And I'm talking about when I was in high school, I thought it was pretty unlikely that a computer would be able to become good at chess. But I was dead wrong, okay? And so,
how did that make you feel, by the way, when you blew big Kasparov?
I stopped playing chess seriously when I encountered computers that could beat me. Okay,
yeah.
I still play with my grandchildren a little bit, but yeah, it seemed like, in a certain sense, it became a solved problem when AI was able to do it better than I could. So I think that there are ways in which today we've seen computers do things which historically were regarded as being very characteristic of human intelligence. And in that sense, there is some success to AI. I also think that, there are certain things which one might think of as being AI, which are, completely widespread in our society. I'm thinking about the internet, search engines, and so forth, which are enormously influential and obviously do things more powerfully than any individual human or even any combination of humans could do, much faster and accessing databases and so on and so forth. All of this is outstripped our human intelligence. I'm not sure the extent, though, to which that is really intelligence in the way that was traditionally meant, but it's certainly amazingly facile, and it multiplies our ability to access human knowledge and data and so forth. So,
is that enter the realm of something we should be concerned about? So, in the realm of religion, you talk about what is good, what is evil, what is right, what is wrong. You have a set of morals, set of beliefs, and when you have an entity come into the picture that's that has quite a bit of power if we potentially look into the future, and intelligence and capability. Do you think there's something that religion can say about artificial intelligence, or is that something we shouldn't worry about until it arrives, you think? Just like with the chess program.
Religious writers have thought about this for centuries. There's been a long debate about what was historically called a plurality of worlds. And it was actually more about whether there are places where other intelligent creatures live than it was about us creating them. But I think it's largely the same question.
It's almost like aliens, like other intelligent life.
So if there is other intelligent life in the universe, what is its relationship to God? Okay, that is, in a certain sense, the puzzle that religious thinkers and writers have thought about for a long time. And there's a whole range of different opinions about that. I mean, personally, I think it's an interesting question, but it's not a very pressing question at the moment. And I think the same way about the question of what happens if we're able to build a sentient robot, for example. I think it's an interesting question, and we'll have to think about it when that happens. But I think we're still quite a ways away from that. And so I don't have a good answer. But I think there's a literature that one could tap to think about. Okay.
If you want to start early on the question. Yeah. Well, let me ask you another possible question. From a religious or from a personal perspective, what do you think is consciousness? This subjective experience that we seem to be having. Does the Christian religion have something to say about consciousness? Does your own, when you look in the mirror, do you have a sense of what is consciousness?
I think the Bible doesn't have much in the way of answers about that directly, in the sense that you're perhaps asking it, which is more like, I think you're asking for some kind of quasi-scientific, or maybe indeed scientific description of consciousness.
Desperately looking for one, yes.
I think that it's an interesting question. I think it's actually it's a jump too far. I think we don't even know the answer to the question, what is the mind, let alone consciousness. So if you distinguish between those two things, I think the question that's being addressed more directly, scientifically, as well as in other ways, it is, what is the mind? And that is certainly a very topical question, even in places like MIT, which is not historically involved with philosophical questions. There are people doing neuroscience and so forth. I think it's a very important question, and I think that we're going to find that we are not computers. In other words, I think the commonplace theory of what mind is generally speaking, by analogy, that we are basically wetware. Okay, that we're some computer-like entity, and that the analogy to digital computers is a pretty decent one. I mean, that's of course a viewpoint which which drives the aspirations of the transhumanists. I mean, they so much believe that our minds are nothing other than, in a certain sense, some kind of implementation of software in biology, that they say to themselves, well, of course we're going to be able to download it into a digital computer. I don't think that's true. I think it's most likely that quantum mechanics is very important in the brain. It seems most unlikely that it's not, to me. I know that that's contrary to the opinions of many people, but that's my view. And it's also a view, for example, of people like Roger Penrose and people like that who've written about it rather extensively. And if that's the case, then really my mind is not reducible to some kind of software which can be considered to be portable. It is so connected to the hardware of my body that the two are inseparable. Okay, and so if that is in fact what we find, as I suspect will be the case, then the aspirations of the transhumanists will be very long in coming, if at all. So I think that actually physics and chemistry are in a sense involved with the brain and within the mind, but not in a very simple way, like the computer analogy. Yeah. In a much more complicated way, and I also think that it's philosophically ignorant to speak as if when and if the actions of the brain are understood at the physical and chemical level, that will mean that the mind will vanish as a concept, that we'll just say, we're nothing but brains, okay? Mm-hmm. Of course it won't. I mean, it may well be that our mind is an emergent phenomenon that comes out of the physics and chemistry and biology, okay? But it's also something that we have to encounter and take seriously. And so, it's not the case that the mind is reducible to nothing but physics and chemistry, even if it's embedded in, continuously into physics and chemistry, as I rather suspect it is. That's my own view. I mean, another way of putting it is that the mind or the soul is not something added into humans, right, as might have been the viewpoint historically. I do think there is something added to humans, but it's not the mind, it's the spirit, and that takes us beyond the physical. It takes us beyond this universe. But I don't think that consciousness, the mind, et cetera, is that thing which is necessarily
it's added in explicitly.
So it
could be emergent in some way.
I'm not a substance dualist in that sense. Okay, if you want to put it philosophically.
I mean, but your sense is so the mind and the intelligence and consciousness can be these emergent things. Do you have a hope, a sense that science could help us get pretty far down the road of understanding?
We will get much further than we have, and it'll be interesting. I mean, right now our methods of diagnosing the human brain are extremely primitive. I mean, the resolution that we have, that comes out of NMR and brain scans and so forth is miserable compared with what we need in order to understand the brain at the cellular level, let alone at the atomic level. But we're making progress. It's relatively slow progress, but it's progress, and people are working on it, and we're going to get better at it, and we'll find out very interesting things as we do. The time resolution is also completely hopeless compared with what we need to understand the thought, So there's a long way to go, and we will get better at it. But I'm not at all worried, as some people are, and some people speak as if it's a good thing, that somehow the concepts of humanity and the mind and religion and consciousness are going to vanish because we're going to have, complete physico-chemical description of the brain in the near future. We're not going to have that. And secondly, even if we had it, the mind and all these other things aren't going to vanish because of it.
Well, I find kind of compelling the notion that whoever created this universe and us did so to understand itself, himself. I mean, there's a powerful self-reflection notion to this whole experiment that we're a part of.
Well, I certainly think that God takes delight in his creation, and that it was created for that delight as much as it was for any other reason, and that that therefore there's reason to be hopeful and awestruck by the creation, whether it's on the very small or on the very large.
I'm not sure if you're familiar. There's something called the simulation hypothesis that's been fun to talk about with computer scientists and so on, which is a kind of thought experiment that proposes that, the entirety of the world around us is a kind of a computer program. That's a simulation, and then we're living inside it. I think from a certain perspective, that could be consistent with a religious view of the world. I mean, you could just use different terms, basically. What are your? But it feels like a more modern, updated version of that. But what's your sense of this of the simulation hypothesis? Do you find it interesting, useful to think about it? Do you find it ridiculous? Do you find it fun? What are your thoughts?
It's fun, and it's been, of course, the subject of various movies.
Yeah.
That some of which are very well known. I don't think it makes sense to think of it as a simulation hypothesis in the sense that we're really lying in banks on banks of beds, having our energy drained away from us,
Right.
and the simulation is going on in our individual brains. That makes no sense to me at all. I don't think that's what's meant by the simulation hypothesis as you're using it now. But I think that there is very little distinction between saying that an intelligent creator has set up the universe according to his will and his plan and set it in motion and is allowing it to run out. Maybe, as Christians say, he's sustaining it, actually, by his word of power, it says in the book of the letter to Hebrews, okay? In this amazingly consistent and integrated way. I don't think there's very much difference between saying that and saying that it's a simulation, okay? I mean, I think it's almost the same thing, okay? But I think it's important to recognize that the simulation in that concept, the simulation and the creation or the universe are the same thing, okay? Mm. In other words, it's a simulation, that is billions of light years across, okay?
Yeah. I mean, there's a sense in which it helps one understand, especially if you're not religious, that there's something outside of the world that we live in, that there's something bigger than the world we live in. And that, I mean, it's just another perspective on that humbles you. So in that sense, it's a powerful thought experiment.
One shortcoming of that is the following, of the analogy, is this. That we think of a simulation as something taking place in the universe. When it's taking place in my computer. Okay, yeah. I don't think that's the right analogy for a Christian view of creation. Okay, I don't think it's taking place in some other universe that God has made. Okay, I think maybe it's taking place in the mind of God. Christians might hypothesize also, but I think that it's important to recognize that Christian theology, at any rate, is that God is not one of the entities in the universe, and presumably, therefore, is very different from a simulation that we might run on a computer.
Let me ask you: Adam and Eve, even Adam, ate of the fruit of the tree of knowledge of good and evil. Is this story meaningful to you? What does this story mean to you?
Yeah, it is meaningful to me. I take the writings of the Bible very seriously, and I think that most Christians regard them as having some kind of authoritative role in their faith. What do I get from it? I mean, I think the most important thing that Christians get from the story of Adam and Eve and the eating the apple and so forth is that the relationship between humans and God is broken. Has been broken by man's disobedience. That's what the story of Adam and Eve and the apple is all about. And that broken relationship is, for Christians, what Jesus came to redeem, came to overcome that brokenness and restore that relationship with God. To some extent, at any rate, on earth, and ultimately, in eternity, to restore it fully. So that's really what Christians mean and gain from the story of Adam and Eve. Of course, lots of people ask the questions about how literally should we take these stories of particularly the first few chapters of Genesis, which is an important question, but we tend to get bogged down with it a bit too much. I think we should take away the message, and I think what actually we would have seen if we'd been there, okay, is something which is a matter of speculation, and it's certainly not terribly important from the point of view of Christian theology.
But it seems like a very important moment. As a man of faith, do you wish that I think it was Eve first?
Yeah, it was Eve that ate.
Do you wish
an apple, by the way? It was just a fruit.
It was a fruit.
You said it very carefully.
It was the fruit of the tree, right? Do you wish they wouldn't have eaten of the tree? I mean, this is back to our discussion of suffering. Was that like an essential thing that needed to happen?
You're going to have to read Paradise Lost to get your answer to that.
Beautifully put. Okay. Well, let me ask the biggest question, one that you also touch in your book, but one that I ask every once in a while is, what is the meaning of life?
The meaning of my life is many different things, okay? But they are all kind of centered around relationships. I mean, for a Christian, one's relationship with God is a crucial part of the meaning of life. But one's relationship with one's family, wife, parents, children, grandchildren in my case, and so forth, those are crucially important. These are all the places where people, whether they're religious or not, find meaning. But ultimately, I think a person who has faith in a creator, who we think has an intention, or many intentions, but a will in respect of the world as a whole, that's a crucial part of meaning. And the idea that my life might have some small significance in the plan of that creator is an amazingly powerful idea that brings meaning. I tell a story in my book that when I was a student, before I became a Christian, I read a philosophy book whose approximate title was "What is the meaning of life?" And that book basically said there is no meaning to life. You have to make up the meaning as you go along. And I think that's probably the predominant secular view is these days, that there is no real meaning, but you can make up a meaning, and that will give you meaning into your life. I don't subscribe to that view anymore. I think there is more meaning than that. But I do think that those things which give meaning to our life are very important, and we should emphasize them.
And you have said that as the part of that meaning, as the part of your faith, love and loyalty are key parts. So can you try to say what is love and loyalty? Like what does it mean to you? What does it look like? If you were to give advice to your children, grandchildren, of what to look for in looking for loyalty and love, what would you try to say?
Well, I think it's something like yielding your will or desire to another. It's valuing others more highly, or at least as highly as yourself. But that's just the start of it, because true love, you reach a point where you feel compelled by the other. And that, I think, to some people sounds very scary, but actually it's terrifically liberating. And I think that love then brings you into service towards another. And I'm, reminded of the phrase from the Anglican prayer book where it talks about Jesus, whose service is perfect freedom. In other words, for us Christians, to serve God is what perfects our freedom. And I think there is an amazing love as is in part captivity, but in a kind of paradoxical sense, it's also an amazing freedom.
Love is freedom. I don't think there's a better way to end it. We started with fusion energy and ending on love. Ian, there's a huge honor to talk to you. Thank you so much for your time today.
Thanks. It was a pleasure.
Thanks for listening to this conversation with Ian Hutchinson, and thank you to our sponsors, Sunbasket and PowerDot. Please consider supporting this podcast by going to sunbasket.com/Lex and use code Lex at checkout, and going to powerdot.com/Lex and use code Lex at checkout. Click the links, buy the stuff. Even just visiting the site is really the best way to support this podcast because it helps convince them to sponsor it in the future. If you enjoy this thing, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, or connect with me on Twitter at Lex Friedman, spelled somehow without the letter E, just Fridman. And now, let me leave you with some words from Arthur C. Clarke. Finally, I would like to assure my many Buddhist, Christian, Hindu, Jewish, and Muslim friends that I am sincerely happy that the religion which chance has given you has contributed to your peace of mind, and often, as Western medical science now reluctantly admits, to your physical well-being. Perhaps it is better to be unsane and happy than sane and unhappy. But it is the best of all to be sane and happy. Whether our descendants can achieve that goal will be the greatest challenge of the future. Indeed, it may well decide whether we have any future. Thank you for listening, and hope to see you next time.